Morning, and India is trying to get some of the best drones in the world. Uh, we have already some of the drones brought from our friend, all-time, all-weather friend, Israel, uh, here on drones. But there is a problem. When we asked America to give us some Predator drones, which we should have bought earlier, the armed variants of the Predator drones, America is hesitating to give from that's the General Atomics Predator drone. The reason for this is sometimes the drones get captured or the platforms we use, the hardware shares signatures are shared by hardware that we buy from an ally close to it, like Russia. So we use a lot of Russian hardware, like it's in S400. And these shared platforms will pick up those signatures and it could be passed on to Russia. So they cannot take that risk and they are unable to sell you these advanced predators. While our own drones are not yet ready. They tried it, but they are not quite, they were doing some trials in the Tibetan plateau, but they were not able to, really make it work, in which case we badly need armed drones. We should have developed it faster. Let us see if we can really fast track the development of weaponization of the drones that we have. It is possible. There is one way in which it could be done. First, let us see why is that some of these best drones cannot be sold to us. Is we bought one drone, and what happened was from Israel, it crashed in the Tibetan area, and the sensitive components had landed with China. It has fallen in China's hands. This happened a couple of years ago. So it's happened December 7th, Indo-China border. So what it is, the Israelis are investigating whether components could have been taken away by the PLA. That is the usual way in which China either steals technology or reverse engineers whatever that falls in its hand. So you can see that China has also simultaneously developed the Predator version or Chinese version of the Predator drone. From these captured, one coming from Iran, another coming to given to Turkey. Turkey had it, and now China reverse engineering. So they are hesitating to give the latest version of the Predator armed drones. So if we see whether we will be able to overcome this problem, yes, it is possible if we take to 3D printing. So that is where let us listen to how rockets are made faster.
And that 3D printing was the only technology that was going to make that future happen faster, and we could actually be that company.
What were the advances that you had to make? Like, there obviously you can't just go and get a MakerBot and start making, rockets with it.
Right.
What were the technological advances that you had to make it possible to 3D print the parts of essentially the entire rocket?
The first thing we had to do is invent the world's largest metal 3D printer.
That's not too hard, though.
Yeah, well, and also YC, we only had 3 months before we got to demo day, so we had to do it very quickly and show progress. So we actually worked a lot on both the material science, the actual physics of how the printing process works so that you get good enough quality for being able to 3D print a rocket. Our whole rocket has about 100 miles of printer kind of length as you build up with these robots layer by layer, sort of like Westworld, but for rockets. Instead of printing people, you're actually making rockets, and that's what the tech looks like. And we actually had to come up with a way to simulate the printing process, develop all the control algorithms using computer vision and collecting that data, and then correlating it with the material science element of inspecting the material quality and building this correlation and learning matrix over time. So that's what we've had to develop to now be able to print full-scale rocket stage structures that we've actually pressure tested and proven that 3D printing works. And we've also done over 250 3D printed rocket engine tests across 20 different versions of the engine. And we've done over 13 different versions of the core printing tech. So it's just been high amounts of iteration and getting the science to work. Over the first 2 years of the company, But then the last 2 years has been about scale. So we went from 14 people to 135 people in the last about year and a half or so, bolstered by, most recently we raised $140 million Series C. Yeah, thank you. So now we're fully funded to get to our first launches, and really capitalizing on the infrastructure agreements we've won. So we actually have a launch site at Cape Canaveral, Florida, which is working with the Air Force. We're only the 4th company to ever get a launch site at the Cape. And then we also have 7 different engine and vehicle test stands at NASA Stennis Space Center exclusively for the next 20 years. So that kind of infrastructure platform lets us develop our 3D printing tech, and is big enablement by these kind of government public-private partnerships to let us build the future.
How close are we to launch, and what do you need to prove to get to launch?
Yeah, so I mean, the most recent milestone on the engine development side is now we actually increased the thrust of the engine from what was 17,000 pound thrust to now 23,000 pound thrust, which normally in hardware takes several years. It's not like a lot of software companies where you can just kind of like click and drag and now it's bigger and everything's fine. So we've had to develop the automation and the workflow tools together with the printing process, and we were able to do that in less than 8 months, which is way faster. I mean, it wouldn't be physically possible with the existing tech. So now we've done full duration turbopump testing of both turbopumps running simultaneously for a full 320-second test, which is the longest it would do during launch. We've done this, kind of full power engine chamber test, and then the printed stage structure test, and of course we're in the avionics lab right now, so all the different electronics and flight software, individual piece parts. And the next major milestone is going to be putting all of that together into a full stage test, which we're on track for this year.
This year?
Yeah, and towards flights next year.
Okay, so assembly this year, launching next year.
Yes, 2021.